Hello everyone. In this session, let's go through the concept of Huffman coding. So the Huffman coding is a technique which produces a data without any losses. And the idea is to assign variable length codes to the input characters. Lengths of the assigned codes are based on the frequencies of corresponding characters. And the main important thing to be noted over here is the frequent characters, that is the repeated characters which are being used, is assigned with the smallest code, and the least used character, that is the characters which are used very less, are coded with the largest code. Now, let's know what is prefix code. Prefix code, which is a language or the code with the binary code, which is a formation of zeros and ones. Let's know the definition. The variable length codes assigned to input characters are prefix code. So for this, let us consider the character as A, and the codes assigned to that are 0 and 0. This is what this line says all about. Means that the codes are assigned in such a way that the codes assigned to one character is not prefix of the code assigned to another character. That means, for example, I've given the character A with 0 0 and my character B would be 0 1. That means there's no repetition of the codes given for one character to the other. So the character to character the code differs. And so this is how Huffman coding makes sure that there is no ambiguity with decoding the generated bit stream. By this, since the characters is given with different codes, you doesn't come across the concept like ambiguity. Since the code are different, there's no possibility of ambiguity. This is what all about prefix code. So let us take an example to more clearly understand about what is the prefix code. Let's consider four characters A, B, C and D with the variable length or the frequencies 0, 0, 0, 1, 0 and 1. That is, the character A is assigned with the frequency 0, 0 and B is assigned with the frequency 0, 1 and C is assigned with the frequency 0 and D is assigned with the frequency 1. Let us take an example 0, 0, 1. After decoding this frequency numbers, we'll get the answer as CCCD because C is assigned to the frequency 0. So 0001 can be assigned as CCCD, and it can also be given as C, C and B because C is 0, C is 0 and B is given by the code 01. Or it can also be given as A, C, D or AB. So this results in ambiguity. So this is not a perfect example of prefix code. This can be considered as not a perfect example for prefix code. So based on the analysis how the Huffman coding has been performed, it has been divided into two major parts. That is, based on the input characters, we need to build a Huffman code tree, and the second important point is traverse the Huffman tree and then assign the code to the characters. Steps to build Huffman tree. So the input we are taking is array of unique characters along with the frequency of occurrences, and the output we get is a proper Huffman tree. So there are 4 steps to build a Huffman tree. Step 1. Create a leaf node for each unique character and build a min heap of all the leaf nodes. So min heap is used as a priority queue. The value of frequency field is used to compare two nodes in min heap. Initially the least characters is at the root. Now in the second step, exactly we'll be having two nodes with the minimum frequency from the minimum heap. In the step 3, create a new internal node with the frequency equal to the sum of two nodes frequency. Make the first extracted node as its left child and the other extracted node as its right child. Add this node to the min heap and repeat the step 2 and step 3 until the heap contains only one node. The remaining node is the root node, and the tree is complete now. So let's consider as B, E, P and then space O, R and exclamatory. Now the character B is having the frequency 3 and E with the frequency 4 and P with the frequency 2 and blank with the frequency 2 and O with the frequency 2 and R with the frequency 1 and exclamatory mark with the frequency 1. Initially, this is not the list which we have. This list is obtained by arranging the numerical values from in ascending order. So in this case, R is assigned with 1 and slash exclamatory mark is assigned with 1 and P is assigned with 2, O is assigned with 2 and space is assigned with 2 and D is assigned with 3 and E is assigned with 4, which is arranged in a numerical order as 1, 1, 2, 2, 2, 3 and 4. Let us take this numerical order and add R with exclamatory, that is 1 with 1, which results in the value 2. Now 2 is a combination of R and exclamatory, where R has a value 1 and exclamatory has a value 1. This is the first initial step what we do. As we discussed in the previous slide, we are going to add the two frequencies and place the sum in the place it needs to be given in the ascending order. The two frequencies were 2 plus 2 and then it is placed 2 plus 2, which is 4, placed in the fourth place and placed in the fourth place. Now 4 is a combination of two other characters, and which is other character with the P, and other character is a combination of R and exclamatory. And this step continues forward. We are going to add 2 and 2. The first 2 is O and other 2 is blank, and it is 4, and place the 4 after 3 because 4 is greater than 3. And now the 4 is a combination of 4 is a combination of O and space. And similarly we are going to continue with the other slides or other steps to be followed. And now we have 4 with 7. We are going to add 4 with 4, which is 8. Since 8 is greater than 7, it will be placed after 7. Now we are going to remain with 7 in 8 and 7 in 8, 7 with B and other character and the other character with a combination of O and slash, and 8 with a combination of character and E and other character and E and other character and R and slash. Now finally we'll get the Huffman tree in this format which is given. Once after the creation of the Huffman tree, what is the next step to be followed? That is, how are we going to print the codes in the using the Huffman tree? So these are the steps to print the codes from the Huffman tree. In the first step, just visit the tree from the root node and maintain an array. So while moving to the left, assign the left-sided values with 0, and while moving to the right, assign the right-sided values with a 1. And print the array when a leaf node is encountered. That is, and print the entire list of array when you encounter the character with the frequency value given previously. So this is a complete tree, Huffman coding tree, which is obtained by performing decoding. So in this case, the value for the B can be given as 0 and 0. Just traversing from the root node to the leaf node. Let's consider an example for R. For R, traverse from the root node. From root node to the next node, the value is 1. From there to the left, we have 0, and again to the left, we have 0, and again to R, we have 0. So the value for the R can be given as 1, 0, 0, and 0. Similarly, all the characters will be getting the coding in this way. These are the values given for the character after performing the Huffman coding, and my characters are B, which is given the code 00, and E 11, and P 101, and blank with 011, and O with 010, and R with 1000, and exclamatory with 100 and 1. So guys, this is the end of the session. of Huffman coding. Thank you.